A very good day, dear students. You know me as your robotics faculty. I'm Shomadip, and let us move to the next section. That is the 15th session for this course. So till now we have learned till functions, right? How to use functions, how to assign functions, and what are the other syntaxes. So let us see what else is waiting for us. Okay. So now here we are with the 15th session. Okay, and let us begin. Data types. So let us start with Arduino data types for now. Okay, and let us see what else is there. So the data types are used to identify the types of data, of course, as the name suggests, and the associated functions for handling the data. Now, it is used to for declaring functions and variables, which determines the bit pattern and the storage space. Okay. So what type of data you are using? Okay, that is what being told over here. All right. Now the data type that we will use in the Arduino are listed below. So some of them you already know, like void data type. Okay, int data type. Int means the integer data type. When we're using numbers, we're working with numbers, right? Whole numbers. Then character data type, which we call as cal. And then comes float data type, where the decimal is being used. Okay. Then comes double data type. Okay. Unsigned int data type. This you might not have used till now. Short data type, long data type, unsigned long data type, byte data type, world data type. So these are some of the data types that are currently in use in Arduino. Okay. Let us study about these data types. The void data type. Now, the void data type basically specifies the empty set of values and only used to declare the functions. That means where it is being used, you all know, right? Void setup, okay, void loop. So whenever the definition need to be given for a code, but it's basically empty. So that means it basically doesn't is not assigned to any value, is not assigned to any kind of mathematical operations yet. Okay, so there we use the void data type. Okay, it is used as the return type for the functions that do not return any value. So if the function is not returning any value, so the void data type is being used. Void means null, right? Empty or vacant. So that is why the name is given void. So if it is not returning any value, we can assign the void data type. We can use the void data type. Okay. So this was it. This was basically it. The example is given, a very short example. Short code snippet is given over here. Int a equal to 3, then void setup and void loop. This is how we begin the program to write. Okay. Next, int data type. Okay. Now the integer data type or int data type are the whole numbers like 5. Okay. It can be negative also. That's why it is called integer. Okay. Not only the whole numbers, but it can be integer, negative integer also. -6, 10, -123, etc. Anything, numerous. Okay. Infinite numbers. Now they do not have any fractional part. That is a condition. So if it is in fractions, then the int data type will not be working or it cannot be assigned. Right. The integer data types are represented by int. Of course, it is known by now. Now, it is considered as the primary data type to store the numbers. Okay, you will use it very frequently, very frequently. Okay. The size of the input is 2 bytes, that is 16 bits. 8 bits make 1 byte, so 16 bits will make 2 bytes. Minimal range 32768 to 32767, or 2 to the power 15 to 2 to the power 15 minus 1. Okay, that's the minimal range. In the Atmega and Arduino Uno boards, the int data type stored the value of 2 bytes. Okay. Now, on the boards like Arduino Zero and MKR 1000 SAMD boards, the Arduino Duo, the int data type stores the value of 4 bytes or 32 bits. All right, there the minimal range in such case would be 2 to the power 31 to 2 to the power 31 minus 1, or minus 2, 147, 486. Okay, so this is the basic difference between the int data type between few types of. Now, when we were studying the types of Arduino, what we saw is that there are few boards which uses the Atmega series. Okay, what we are using Atmega 328. So similarly, some Atmega series is being used, and there are other boards which doesn't use that Atmega. So it makes a difference between these characteristics. Okay, like the data type, the minimal range. Okay, the bytes, the size of working. So these are the differences. So let us move further. The negative numbers are stored in the form of 2's complement. It means where the sign bit or the highest bit is flagged as the negative number. Okay. This is just a concept that you need to remember, keep in mind. The syntax is used as int var equal to val. That means var means variable, and val stands for, that's VL stands for the value assigned to the variable. Now, for example, int a, int b equal to 3. Now, any variable or identifier becomes an integer variable and can hold only integer value. That you need to remember. Okay, let us move further. Example, the best way to understand. If we say int sum equal to 0, and then we start our code, void setup. Inside void setup, we have a serial dot begin to be 9600. We have set it up. Void loop. Inside void loop, we have sum plus plus. That means sum plus 1. Okay, whatever the value would be, it would be increased by 1. Okay, serial dot println sum. That means in the next line, new line, the sum would be printed every time, and then delay 1500. Okay, all right, this is how it can be used. Now, you see, these are the things now I have discussed earlier also in the earlier sessions, but still, if you don't remember, let me just give you a short recap. Inside the void loop, if you see sum plus plus, that means sum plus 1. That means whenever the sum will be done, the answer again, since it is in the loop now, so it will be a repeated sum continuously. Now, sum plus plus will be sum plus 1. It means sum plus 1. That means the answer would be added 1 each time and printed in the next line. Why next line? Because the students remember serial.println. ln stands for line, right? So if you say, if you would have wrote serial.print, right? So new line option would not be there. Okay, it would have been printed continuously. That's what I wanted to make you remember. All right, let us move further. char data type. Char means character data type. Okay, the short form for character. The char data type can store any number of characters set. Okay, an identifier declared as the char becomes a character variable. The literals are written inside a single quote. Whenever we are mentioning any kind of character, dear students, anything can be assigned as a character. Okay, even the numeric values can be assigned as a character. Now the thing is, we need to write it within a single quote to consider it to be a character. Okay, that is how we assign the value. That is how we declare it. All right. The char type is often said to be an integer type. It is because symbols, letters, etc. are represented in memory by associated numbers, number codes, and that are only integers. Okay, that is why it is said as such. The size of character data type is minimum of 8 bits. We can use the byte data type for an unsigned character data type or 8 bits or 1 byte. For example, character within quotes A, right, has the ASCII value of 65. Now, if we specify A plus 2, it will have the ASCII value of 67. Understood? If we perform any kind of mathematical operation with the characters, right, including the characters, then basically what we are doing is we are performing the mathematical operation with the ASCII value of the character. Okay, because value character cannot increment as 1, 2, 3. Okay, what we are doing is performing the operation, performing the function with the ASCII value. Okay, now for example, you see the syntax. What is the syntax? Char val char var equal to val. So again, similar to int, character is also defined like that. Okay, I hope you have understood what the char data type. Now this is one of the most common, int and char. These two, one of the most common data types. In, you can not say not only in Arduino but in every coding language. Okay, every now and then, every few seconds, you will be working with these two. Example. See, char my variable equal to capital B, char my variable equal to what? 66. That means both the values are equivalent. Okay, because we are assigning it, right? Okay. This is something that you cannot remember, I know, but I just wanted to show you the ASCII table. Okay. This is the ASCII table, and decimal and hex both are being shown over here. Okay. And the keys also, if you can see. I hope you have understood. See what we just said. If you remember this, a plus 2 will be 67 because a is 65. What is this? This is the decimal. A is 65 basically. So a plus 2 would be C, that is 67. 65 plus 2, 67. This is what we talked about. Okay, basically we considered the decimal part only. Okay, and the hex is also given, that is hexadecimal part is also given. But basically when we say the ASCII value is this for a digit, for an alphabet, for a symbol, what we say is the decimal values. Now, float data type. A number having the fractional part and a decimal part is considered as a floating point number. What is the full form? Floating point number. Okay. So if you have a fraction, no, fraction and decimal, they are the same things basically. Okay, just in two different formats. Okay. For example, 4.567 is a floating point number. Okay, they are called float. The number 13 is an integer, while 13.0 is a floating point number. Now you see 13 and 13.0, there is no difference between both of them mathematically, right? Mathematically, they are absolutely same, right? 100% same. But the thing is, when we are talking about programming language like C and Arduino, anything, so when we write 13 and when we write 13.0, both becomes very different because why? The type of the character of the number changes, right? So in one we are writing 13 as an integer, in another in the second time, but we are writing 13 as a decimal number, right? We are writing it to be 0.0. Maybe it doesn't mean something mathematically, both are same, but the type is getting varied in a programming language, right? One is a decimal and one is a simple whole number or integer. So that is why 13 and 13.0 are totally different types. One is int, that is integer, other is float, that is floating type variable. I hope this thing is clear to you. Okay. Now, due to their greater resolution, fractional numbers are used to approximate the contiguous and analog values. Okay, the more fraction we give, the more accurate the value becomes. Okay, the more precise the value becomes because it comes closer to the original value, right? Now, floating point numbers can also be written in the exponent form. Okay, it can also be written in the exponent form. The numbers can be as large as 3.4028235e plus 38. Now you see this is the hexadecimal form given whenever you see a combination of number and alphabets. Okay, don't be scared. And as small as minus 3.4028235e plus 38. Now the size of float and data type is 4 bytes or 32 bits. That you need to remember or keep that in mind. How the syntax is? Again, float var equal to val. So var and val, that is variable and value, both are same as before. Just in place of int or char, put float. That's it. Okay, easy to use, easy to put. But what you need to do is you need to remember the concept behind it, when to use float, when to use int, and vice versa. Okay, that was it. Let us move further and see an example. Int a is mentioned, int b mentioned, float c is mentioned. Okay, now when within void setup, serial.begin 9600. Within void loop, a is assigned to be 3, b is assigned to be a by 2, and c, can you see c is assigned to be float a by 2.0, right? Okay, why it is being assigned as a float? Now try to understand. Because if we divide 3 by 2, if we divide 3 by 2 and we take two forms, like for example in mathematics what we will do, we simply divide 3 by 2 and we get 1.5. But both are different in case of computer language, programming language. So when we are dividing 3 by 2, if we get 1.5, and if we change the type of the variable used over here, like for example, if we say to be it to be int, and we don't need to mention it, basically if it is int, it will give the answer in int only by default. So 3 by 2 would be 1. No, that might be surprising. That's how 3 by 2 is 1. It's 1.5, you know. But you see, if it is an int data form, data type, okay, then it cannot print the fractional value. It will print the value that comes first in the line of division. So if we go by formula, the normal division method, when we divide 3 by 2, first we get it 2 into 1 is 2, then 3 minus 2 will be 1, then we put a point beside 1 in the quotient and then add 0, and 2 5s are 10. That is how we divide. So the answer becomes 1.5. Now, whenever the first thing is being done, that is 2 on the 2 is done, and the code ends there because the data type that we want is an integer. Beyond this stage, there will be no integers, right? But like in the same thing can be more accurate or more precise by using float. How? If we use the float data type, then it is already we are giving the liberty to consider the fractional values, consider the points, right? And the numbers after the points. Okay. So at that time, 1.5, we can find out the answer to. This is the whole difference. Very easy, very simple to understand. Yet people get confused. Okay. See. Float a equal to 3.6. Int b, a plus 0.6. Now, if it is int, what will happen? The output is 4. Okay. And why we have defined float a? Why not int a? Because 3.6 is a decimal number. Okay. Understood? So that is the whole concept behind it. All right. Let us move further. Double data type. What is double data type? The double data type is also used for handling the decimal or floating point numbers. It occupies twice as much memory as float. Okay, so the memory allocation, the memory space is more than float, and it is twice than float basically. It stores floating point numbers with larger precision and range. It stands for double precision. Okay, that's why it's called double. It occupies 4 bytes in Atmega and Uno boards, while 8 bytes on Arduino Duo. Different boards, different memory allocation. Okay. The syntax is double var equal to val, so nothing different in that. Now comes something you might not have heard about. Okay, might not, called the unsigned int data type. What is this? The unsigned int stores the value up to 2 bytes or 16 bits. Okay, it stores only positive values. All right. The range of unsigned int data type is from 0 to 65,535 or 0 to 2 to the power 16 minus 1. This is the range. Okay. We're not using it in the code. Okay. Nothing to do with that. Just for your knowledge, just to know. Okay. All right. Then Arduino Duo. So Arduino Duo stores the unsigned data value of 4 bytes or 32 bits. The difference between unsigned and signal and signed data type is the signed bit, right? The int type in. Now Arduino is the signed int. Okay, in a 16-bit number, 15 bits are interpreted with the 2's complement, while the high bit is interpreted as the positive or negative number. If the high bit is 1, then it is considered as a negative number. Okay, that is it. What is the syntax? You see, same. Unsigned int var equal to val. Okay, and how it is used? You see, unsigned int pin of LED equal to 8. Okay, this is how it is being written in real time. The short data type. The short is an integer data type that stores 2 bytes or 16 bit of data. Okay. The range of short data types is from minus 32768 to plus 32768. Okay. Or it is 2 to the power 15 to 2 to the power 15 minus 1. Okay. Minus 2 to the power 15 to 2 to the power 15 minus 1. Okay. That you need to remember. The ARM and Atmega that is the ARM and the Atmega based Arduinos, usually stores the data values of 2 bytes. What is the syntax? Same, short, var equal to val. Okay, we don't need to worry about the syntax for everything because all the syntaxes are more or less same, right? Okay, that you have witnessed till now, maybe. Now, for example, how do we write it in the real time? In real time code, again, short, pin of LED equal to 8. Okay, now don't think that set is saying 8, so we have to give 8. Nothing like that. Okay, the first part is important. All right. Next. So this is the long data type. Okay, as I've said previously also. The long data types are considered as the extended size variables. Okay, which store 4 bytes, that is 32 bits. And the size range is again this one, the same. While using integer numbers, at least one of the numbers should be followed by L, which forces the number to be a long data type. Okay, so if the number is followed by an L, it forces the number to be a long data type. All right. Okay. What is the syntax? Long var equal to var. See below. Long speed equal to 186,000 L. All right. Unsigned we have seen. Unsigned long. The combination of both of them. So the unsigned long data types are also considered as the extended size variables, which store 4 bytes, that is 32 bits. All right. It does not store negative numbers like other unsigned data types, which makes their size ranges to from 0 to 4294967,295, or that is also in short, we can say 2 to the power 32 minus 1. Okay. All right. What is the syntax? The syntax is unsigned long var equal to val. See, without the don't need to remember the syntax as an extra thing, right? It is same for all of them. Okay. Now, if anybody was confused about the byte, okay, what is it? 1 byte is equal to 8 bits. You must know that actually, but still I'm saying it to you. No worries. No confusion should remain. It is considered as an unsigned number which stores value from 0 to 255. Okay. Now, what is the syntax? Byte var equal to val. Same as everybody else. Okay. Word. It is considered as an unsigned number of 16 bits or 2 bytes which stores values. Okay. From 0 to 65535. What is the syntax? Again, the same. All right. No worries about the syntax. This is how it is being written. All right. So that is it, dear students. I hope you have understood all the data types. These were the most commonly used data types, and with continuous usage of them, you'd get habituated with it. Okay. So thank you very much for being so patient. We shall meet again in the next session.